In this lesson, we're going to take a look at a couple relationships within triangles and how we can find some proportions within triangles. Remember we talked about mid-segments? When we have a mid-segment here, these are the same lengths, these are the midpoints, and these two sides, this is 1/2. So if this is 10, this is 5. So the mid-segment is half. Well, we'll generalize that. We're going to also look at what happens when we have an angle bisector. We get some interesting relationships there. So the first thing we're going to look at here is what happens when we have parallel sides, like when we have a mid-segment. So if we got a triangle, something like this, and we're going to draw a line that is parallel to the base. So here we got parallel lines. Well, what happens is it cuts these into four pieces. Let's call this A, B, C, and D. All right, and we know that when we're talking about mid-segments that these pieces are exactly the same because they're midpoints, right? A and B would be the same, C and D would be the same. But what happens in general is if these are parallel, these parts are proportional. It works kind of nice because the proportion is A over B equals C over D. And if we look close, the pieces, if you set them up, kind of turn your triangle in the right way, they make the proportion. A over B equals C over D. The pieces are proportional, and that's simply how it works, all right? And the converse is also true. If we can show that they're proportional, well, that means that the two lines are parallel. So here we got a diagram, and we have these parallel lines in a triangle. And we're told that QR is 4, so this guy's 4. ST is 6. QU is 9. We want to find this little guy here. All right, QR. So we want to find that length. Let's call it X. Well, we've got a proportion, just like we had before there. So let's see here. So let's take Q over, or I'm sorry, that X over the 9. All right, we got X over 9 equals 4 over 6. We can cross multiply that thing. And so 6 times X equals 4 times 9. Cross multiplying in proportions. 6X, 4 times 9 is 36. Let's divide. And we get X equals 6. Not too tough, huh? All right, now we can also use this to find out if these are parallel lines. So here we have a triangle with a line drawn in, and we've got these parts. We want to know if they're parallel. Well, it helps to kind of spin this around, and unfortunately in this program I can't just flip it around, but I'll draw a picture. Let's see. If we flip this around, yeah, we got something like this. We've got a 72 and a 40. We've got a 90 and a 50 in this line that kind of chops it off kind of like that. So we want to know if those are proportional, and if they are, well, then they'll be parallel. So we've got 72 over 40 equals 90 over 50. How do we solve a proportion? Well, here, by the way, we're checking. We should put a question mark there. We don't know. So we can check by cross multiplying. 72 times 50, is that equal to 40 times 90? Let's check that out and go to your calculator. And we'll see if it is. And it turns out that, yeah, both of these are 3,600. So, yes, PS is parallel to QR. All right? There we have it. Okay, so that's how we use what we call, this is called the side splitter, by the way, because it's splitting the sides in two, and it's just hilarious, like a side splitting joke. Okay, so another name for this here is the side splitter theorem. Okay, all right, well, let's generalize this even a little bit more. So here's another little theorem that says, well, if we have some parallel lines and we have a couple transversals, these parts in the middle are going to be proportional. And what's going on here is we're saying, well, if we continue this on, we'd have like this giant triangle there, okay? Kind of see that big, ugly triangle there? Let's see. How about like this? Okay, we get this kind of big triangle if we continue those lines on there, okay? And so what we just talked about kind of applies there, all right? So that's what's going on. So these parts will be proportional, okay? So if these lines, if we got some parallel lines, all these parts will be proportional. Let's try it out here. So we got some examples here, okay? So here we have some lines that are parallel. We want to find the lengths of these here, okay? So we're told, where are we told? Well, we're not necessarily told, so we're assuming, I don't see the lines there, but these guys are parallel. So we've got some parallel lines. So these parts are proportional, okay? Oh, you know what? Here we go. We're told right here, all these angles are congruent. They're all corresponding angles. That makes these lines parallel, all right? So let's find BD. BD is this value x right here. Well, we've got a proportion. We're going to use those two to make one fraction, x over 30 equals these two, 16 over 40. And if you turn the screen around, you'll see, hey, this makes a nice proportion if we're kind of looking sideways, okay? And so, yeah, we can work with that there, okay? We got large numbers. Let's try using our little technique to simplify this. You don't have to, but I think 4 goes into each of these. In fact, 8 goes into each of these. So divide this by 8 and you get 2. Divide this by 8, you get 5. Those are easy numbers to deal with. So now let's cross multiply. 2 times 30 equals 5x. Well, that's 60 equals 5x. And we have divide by 5, and we got 12. Ta-da! We got it. Okay? Well, over here we have JM. Maybe you want to pause the video and try this out right now. See if you can do it for yourself, can you? You see your proportion? We've got, there's those two sides make one fraction. Those two sides make one fraction. Okay? So we've got 15 over 18 equals 16 over x. Or if you wanted to flip that around, you could. 15 over 18 equals 16 over x. And again, let's use our little technique of simplifying because I think 3 goes into each of these. So if we divide each of these by 3, just to simplify it, 5 over 6 equals 16 over x. Now our numbers are a little smaller. Let's try that. 6 times 16 equals 5x. Well, 6 times 16, that's going to be 70, and 36 is going to be 106. And if we divide by 5, well, that's 106 fifths. So x is 106 fifths. All right, now last little theorem here that gives us proportions is called the angle bisector theorem. And what happens is this: if we have a triangle and we take an angle bisector, it makes two parts that are proportional. It cuts this side into two equal parts, and let me draw a different drawing here. So let's take our triangle like this. Nice straight lines, you like that? Okay. And we're going to put an angle bisector in here. Okay? Now, notice we've got a small side, I'm going to call it A, and a larger side B. Notice those are smaller. Now, notice it cuts, I didn't draw this perfectly, but anyways, it cuts this into a small piece here and a large piece there. So we have A over C is going to be equal to B over D. Okay? So that's our proportion. And again, it makes a nice proportion because we just take, if you turn your triangle right, you have this piece over this piece equals this piece over this piece. So that's what we got. Let's try it out. Okay? So here we have a triangle, and we've got two pieces, and we're going to connect these two pieces and these two pieces. Those are going to be our fraction, okay? So we got 48 over x equals, because the side matches with the piece, so match the side with the piece, equals 24 over 14. Now, if you want to flip those around, call it x over 24 and 14 over 24. Sorry, x over 48 equals 14 over 24. That's just fine. Let's cross multiply. 14 times 48 equals 24 times x. And we'll divide by 24 and figure out what that big old mess is. All right, so we get, that's going to give us 28. All right, that's the idea. That's how it works, okay? So one last little example here. What if we have this situation where we know this whole side is 15 and this guy is x? Well, we need something for this. Well, if the whole side's 15 and this is x, and if we take 15 and subtract x off of that, we get 15 minus x. So this piece here is 15 minus x, okay? And so now let's take those two pieces and those two pieces and make a proportion. 13 over x equals 7 over 15 minus x. And now we can cross multiply. 7 times x equals 13 times 15 minus x. Don't forget those parentheses. We can distribute here. 13 times x, well, 10 times x is 150, and 3x is 45, so it's going to be 195. 13 times x is 13x. Let's add 13x to both sides. And we get 20x equals 195. Divide by 20. And it's not going to go in there perfectly. So we can simplify this. We could divide both these by 5. Divide that by 5. Divide that by 5. And we get 39 over 4. Let's leave it alone like that. All right. So that's how that works. That's the angle bisector theorem in triangles. So go ahead now and you can work on your assignment and use those there. And good luck.